Electronic Private Limited, Noida, and he is currently an assistant professor with the Biomedical System Laboratory, School of Electrical Sciences, IIT Bhubaneshwar. And he has published more than 70 research articles in reputed journals and conferences proceedings. His area of interest including electronic system design, signal and image processing, machine learning, and Internet of Things. His research group is awarded with the sponsored research grants more than 4.5 crore in design and development of digital compressed sensing encoder, ADC and AIC data acquisition system, wearable medical devices, digital stethoscope, UWB radar-based human sensing, cognitive radio for M2M and IoT applications, speech recognition system, education, IoT-enabled climate-aware health prediction systems, ICT data analytics system for precision agriculture and IoT-enabled power quality monitoring system. He also served as a technical consultant to the startups. Dr. Manikandan was a recipient of the 2012 Outstanding Performance Award during his tenure at Samsung India Electronic Private Limited, and he is the Associate Editor of Healthcare Technology Letters. He served as the reviewer for many journals of the IEEE, ACM, IT, Springer, Elsewhere, and Taylor Francis. Welcome, sir. Once again, I welcome you.
Yeah, good afternoon to all. Thank you for introducing. And first of all, I thank the organizers for the invitation letter to deliver a talk in Attend Faculty Development Program with a focus of IoT for Smart City. Can you see my slides on full screen?
Yes, sir. Yes, sir.
Yeah, yes, sir.
Yes, yes. Thank you. Thank you so much. Yeah. So, yeah, for this faculty development programs, I have agreed to deliver a talk on Internet of Medical Things, enabled smart healthcare systems in smart cities, and with a focus of concept and key challenges. So, as a participants, as a researchers, and we know that this Internet of Medical Thing is become a popular nowadays with some objectives in terms of technology developments and also business products, business-oriented products. So now, what are the challenges when we want to develop smart cities with the focus of smart healthcare systems? Enabled with Internet of Medical Things and artificial intelligence network. So if you see the evaluation of Internet of Things, in many of the applications, or you can say in many of the scenarios, we are not able to identify what is the exact application of this IoT platform. We'll see what is the major difference between the traditional device-to-device communications, machine-to-machine communications, and cyber-physical systems with the new terminologies, Internet of Things. And nowadays, you can see that there are many engineering disciplines. You will find artificial intelligence-based data analytics. So we are looking for intelligent automated systems where we are able to detect, locate, and recognize, and also to predict the future events based on the large amount of data which are collected from a different types of sensors embedded with any kind of objects. So it's become a physical objects. So when you see the signals and systems subject, and you can find anything measurable or any physical quantity measurable from objects, okay, which are called as signals, which should reflect a time-varying phenomena. So therefore, we are using heterogeneous sensors to understand the normal and abnormal functioning of different types of physical systems. Okay, it can be electrical systems, it can be mechanical systems, it can be chemical systems, or it can be chemical process, or it can be any human organ systems. So now why we collect a large amount of data, and how do you collect a large amount of data simultaneously. So these are the most important things that we need to address when you want to develop intelligent automated systems. So if you see any kind of systems functionings, and one can notice that the function of that particular systems will be affected with the various parameters. Let us take a heart organ systems. We know that the different abnormalities in the heart events when heart is infected with some kind of defects or any kind of injuries, muscle injuries, we'll see the malfunctioning of the heart. So we immediately go to doctors, and then they will record the ECG signals by using a ECG sensor, which is called AGCL electrodes. That can be a 12 leads or a 8 leads, or it can be 3 leads, or it can be single leads. So you'll find the 12 leads on the body, and they'll simultaneously record ECG signals. And also they'll try to collect some more informations, which are called vital sign parameters, which is blood pressures and respiration rate, body temperatures, and SpO2, that is blood oxygen saturations. Now, all these clinical parameters are used to diagnose different type of cardiovascular disease. But we can see that the function of this heart is not only what is called affect or impacted, or not only affected with muscle injuries or any kind of infections in the heart, or any kind of blood flow, means issues in the blood flows through arteries of the heart organs. But it also that under different physical activities, so also change the function of the heart, and different emotional states of a person's also change the function of the heart. You can see that if somebody is so excited, then heart rate may be very high. If it is somebody is so sad and not happy and dull, and then heart rate will be too low. Or somebody is sleeping or walking, jogging and running, then heart rate will be different, blood pressure will be different. So therefore, we have to collect a wide variety of parameters, or we can say heterogeneous parameters, that highly impact the functions of the heart. For that purpose, we must have a device which should be enabled with different kinds of wireless modules, which can continuously sense and transmit to the cloud. That we have seen nowadays in the research, that we use a set of sensors, wireless sensors, which are called wireless sensor nodes, and then we'll collect the different kinds of parameters from a human body in addition to environmental parameters, and then we'll transmit to the cloud to perform a different kind of diagnosis of a cardiovascular disease. But there are some applications we want to take a timely, we want to provide a timely treatment. Therefore, we need to perform such a clinical feature extractions on the device. So now this AI-powered health data analytics, it's kind of empowering the real application of Internet of Things. So since we are going to use this Internet of Things platform or IoT platform to sense only the biological parameters from the human body, which is also a part of medical body area networks. So therefore, there is a variant in the IoT. It's called Internet of Medical Things or Internet of Health Things. Now, as I mentioned that we will collect all wide variety of data from a human body by using this IoT-enabled systems or devices, and then we will transmit to any kind of edge computing server or a cloud computing server. Now, we have to understand what in by edge computing, what in by cloud computing, and also mist computing and fog computing, where we will perform a computations of, or we can say extraction of various features and parameters from the sensed biomedical signals, which can be performed on the device, or it can be performed on the edge computing platform or a server, or which will be performed on a cloud server. So that depends upon the application scenario. And for all these things, the signal processing is most important component to enable this type of technology for a practical applications. So signal processing will play a major role in all three stages. How how efficiently we design a system which can consume less energy in order to detect a different type of arrhythmias or disease. So before moving to this Internet of Medical Things, we can see there is a change in the society. So society 1.0, hunter-gatherer society. This is the pictorial representations. So to understand the evaluation of a societies from the hunting society to super smart society, which is treated as a 5.0. So society 2.0, agrarian societies related to the farming and creating food products, and then society 3.0, industrial society, and society 4.0, it's an information society. But as per the sustainable development goals of this company, which is business federations, they proposed society 5.0, which is aimed at tackling social challenges and achieving a sustainable, inclusive, people-oriented society. So these are the different vision documents to what is called develop a society 5.0. Okay, which is called a super smart society, which includes all components of the society 1. Still we can see society 1, society 2, society 3, society 4.0, and now we are talking about society 5.0. It goes like this way, that it's a super smart society, and then which is from the 21st century. So now in terms of entering society 5. We can say constructing a platform for a society 5.0. So what are the technologies which are most essential to create or to achieve a society 5.0? So one of the major thing is that the concept of smarts. Okay, we can find a smart transportation, smart sensing in the level of devices, smart systems, then smart city, and then smart healthcare. So you will find the term smart everywhere. There is a lot of meaning involved in smart manufacturing systems, also one of the smart technologies. So if you see the real evolution of the internet, there is a network, host and host.
Excuse me, sir. Sorry
Yes.
to interrupt you.
Yes.
So slides not moving.
I'm just moving the slides. 1 minute. Wait, I'll change the sharing. Can you see the slide now?
Yes, sir. Now we can see. Yes, sir.
Yeah, slide number 4.
Yes, sir. Slide number 4.
Yeah, sorry.
Yes.
Yeah, just this is slide 1 that just describe the different society 1.0, society 2.0, society 3.0, society 4.0. Now there is a proposals from Japanese government that to create a sustainable development goals with the concept of smart society, which is called society 5.0. So these the classifications or categorization of this type of societies are based on the technologies that are evolved during this period. So we are expecting the society 5.0 from the 21st century as per this Sustainable Development Goals. And yes. So now we have seen this type of growth in our even in our institution campus. That when you see, you started with some kind of communications between two computers, and then we move to the internet world, then where all the computers are connected with this web. Okay, that's called internet. Then we move to the mobile internet. We will find the uh, interactive communications between the handheld devices and the computers. Then we have seen mobiles plus people plus PCs. So people also involved in the communications. Then we are seeing Internet of Things, which is called interconnected objects. So it is going to connect all objects. Object means any kind of systems. Okay, so therefore sometimes we can see system of system. Okay, so now let us start with the device to device communications example, and then device to device machine communications and internet of computers. Then we have learned wireless sensor networks, then machine to machine communications, then cyber physical systems, internet of things, internet of everything. Okay. So the device-to-device communications is one of the traditional technologies. When you try to see, there is a TV, there is a remote. So the remote is used to control the set of functions of the TV. Okay, so device-to-device communications. So there are some applications device to machine. There are some applications is what is called data transfers between the computers, internet of computers. Then we have developed a miniaturized wireless sensor network, which are capable to sense low data, low data rate um, informations. For example, sensing a temperature, sensing the humidity, sensing the soil moistures, sensing the water quality, sensing the air quality, sensing some other low data rate informations. In the sense that you will find application of wireless sensors to collect a few samples per seconds, not that huge number of samples per seconds. You will find n number of applications, okay, for sensing a low data rate informations. As I mentioned, the temperature. So we will try to sense the temperature of a, for example, ambient temperature once in one samples per minute or one samples per 30 seconds, not like 1,000 samples per second, which we follow in biomedical signals, like a soil moisture. Okay, we'll sense one sample, that is one readings, one sample in the sense one readings, one sample represented with for example 12 bit or 16 bit. So this is the most important applications of wireless sensor networks. But we want to extend the application of wireless sensor networks for a sensing of audios. For example, we want to understand some kind of a suspicious activities in the forest. So the suspicious activities can be means developed means sensed by collecting different kinds of sounds produced at the forest environment. So you will find various kinds of sounds, but so also we know that the sampling rate which is required to acquire sound signals having a frequencies from 20 to 20 kilohertz will be like 8 kilohertz, 16 kilohertz, 32 kilohertz, or 44.1 kilohertz. That means what? That many number of samples will be generated. But as I mentioned that this wireless sensor, traditional wireless sensor network has some kind of a limitations in terms of your data rate, because we use standards, okay, standards for choosing wireless modules. So let us take a Bluetooth, let us take a Wi-Fi, let us take a LoRa, let us take a Zigbee. Now, depending on the data rate of this type of wireless modules, then we can understand that whether we can use this WSNs for sensing of audio. So sometimes we'll sense and transmit, then we'll perform the detection task at the cloud. Sometimes we'll sense and we process, we detect the particular suspicious activities, then we'll communicate to the care providers or some kind of a supervisor. So depending on the application scenarios, depending on the data that need to be sensed, then we can understand the limitations of each of this what is called wireless sensor network application devices. Then we have seen machine-to-machine communications, cyber physical systems, and Internet of Things. So now you can see that we are in the era of Internet of Things, where we are talking that 50 billions device will be connected to the Internet world. So now what is the difference between Internet of Things and cyber physical system? But if you look at the real applications of all these modules, that includes the sensors and processor and wireless communication. Then the key challenges will be improving the accuracy and reliability of some of the intelligent automated systems and providing the intelligence so that we can further improve the accuracy of the systems. And we need to ensure that device security and the data securities when we connect the device to the internet world. And we have to design a systems which can have a low latency. It means that less processing time, and also we have to identify mechanisms to improve the lifetime of the battery operated devices. So now what do you mean by Internet of Things? Let us take one good examples which are reported in the literature. One is Internet of Computers, we know. So there is a human interactions, there is a smart devices. It's called smartphone. So now we find a person's carrying an umbrella. Now umbrella is one of the objects. Okay. Now we want to make this umbrella. Let us take this is a dead object. Okay. We want to convert this dead object into a live object. Live object in the sense we are going to understand the entire functionality of this umbrella by providing some electronic circuitry, in the sense sensors. So whenever we enable any kind of objects with the sensing elements, then it means we are going to provide the liveness to the particular objects. For example, even a human body, if we do not have any kinds of sensations, so even if somebody is alive, also we'll say sometimes it's a joke, we'll say it's a dead body, it's not responding. So similarly, that if you enable any kind of objects where we want to understand the function of that object with the sensing elements, and also your communications elements, communication devices or modules, then we are able to remotely monitor the entire function of such objects that become a live objects. So sensing elements is to understand the real-time functioning of each parts of this umbrella. I'm taking umbrella as one of the examples, but let us take the autonomous vehicle, or you take even what is called driver-based vehicles, car, traditional car. There are many engines, there are many mechanical parts. So now we want to understand the functions of that engines and the mechanical parts remotely from remote locations. Then we must enable those engines and the mechanical parts with a set of sensing elements. Okay. So you enabled with the sensing elements. That means we are what is called measuring the what is called physical parameters, or you can say physical phenomena. It is going to reflect the measured data going to reflect the time-varying physical phenomena of the each of the parts of the engine or a car or a umbrella. Now we collected this informations which are called as signals. Okay, time-varying phenomena which are called as signals. If there is no time-varying phenomena effect on any kinds of object, then there is no meaning in observing the function of the device. So therefore, we have to see the uncertainty concept, entropy concept. That is, but fortunately, most of the physical objects has the time-varying phenomena characteristics, but the time-varying characteristics may be a short duration, or it can be a medium duration, or it can be a long duration in terms of, I can say, milliseconds, in terms of nanoseconds, or in terms of seconds, in terms of minutes, in terms of hours, or in terms of days, in terms of month, or in terms of year. So that depends upon the type of object that need to be monitored. Some system will have varying characteristics in a fraction of seconds. Some system have varying characteristics for in a day. Some system will have varying characteristics after a week. So that depends upon the type of system, in the sense object that need to be monitored in a practical scenarios. But fortunately, all the physical systems, physical objects that we see in the real world are going to have the time-varying characteristics, but the time-varying durations always differs with respect to the actual characteristics of that particular systems. Okay, so that's the application. Now, we described the applications of monitoring the function of this umbrella. But this umbrella always used by this type of persons. So now, in addition to understanding the function of this type of umbrella, I can also use this umbrella for sensing other environmental parameters in the surrounding area of any kind of a users. So let us, in a city, okay, thousands people are using umbrella in a day in a particular zone, and if all the umbrellas are enabled with some kind of weather sensors, some kind of water quality sensors, air quality sensors, then they are able to provide environmental informations to the cloud systems, or one can understand what is the what is called climate conditions or air quality parameters in a particular zone. So this is called crowdsourcing. It is called collaborative sensing. Okay, that means what many users are regularly using the umbrellas. Many users are regularly using the car. Many users are regularly using a two-wheeler. But we have seen a application of this type of IoT system for understanding the function of such objects, either a car or a umbrella or a scooter or a bicycle. Now we are trying to use this type of objects to sense other parameters which will be useful for other users. So that's called collaborative sensing. So now one can sense, that device can sense, or you can say this umbrella can sense air quality parameters which can communicate to this. Or when you carry the umbrella, you can sense the physiological parameters of the users and it can communicate to this. So we must understand what is the main difference between the cyber physical systems and Internet of Things. If you go through the literatures, and you'll find this type of explanations and descriptions about IoT and the cyber physical system. Internet of Things is about connecting things or objects, as I mentioned, physical object, or it can be machines to the internet and eventually to each other, while cyber physical systems are integration of a sensing, computations, networking, and control components tightly coupled with the physical objects and infrastructures. For example, autonomous car or autonomous vehicle, smart grid, medical systems at hospitals. These are called cyber physical system because that integrates a sensors, sensing elements, computing elements, and also a set of networking elements and with the control elements. It's a tightly coupled with the physical objects that need to be monitored in a real time. IoT devices talk directly to each other and make a joint decisions and exchange data between devices without the need for the cloud and servers. So now this description is questionable. Okay, we can argue like this because we have seen IoT based cloud computings. Okay, so it is not that we can define any kinds of technologies, okay, by enabling with some kind of a features, salient features. Otherwise, there is no hardcore definitions for IoT. Means it should have any kind of a law or any kind of a lemma or any kind of a prepositions as to follow. Like we studied energy, power, periodic, non-periodic, causal, non-causal systems. There are standard mathematical proof and concepts. Here there is no such a. If you add some kind of a salient features, and one can define the new type of technologies in their aspect or with respect to the applications, with respect to various salient features as which are available with the current technologies as compared to the past technologies. So therefore, this can be questionable that some can say, one thing we can say that we can make a joint decisions. For example, we used wireless sensors node for sensing soil moistures. Okay, once you sense the soil moisture or based on soil conductivity sensor, and then one can enable the pumping of the water or switch on the water irrigation systems. Now, if you want to add some kind of intelligence to this pumping mechanisms, that is, while soil moisture is, for example, soil moisture is low, okay, so that means we need to pump the water. So one can design a system, just switch on the motor and enable the drip irrigation system or water irrigation system. Or alternatively, one can have some kind of intelligence also. It can sense the weather. What is the weather now? Even though soil moisture is low, we'll see the weather conditions. It's going to rain in a minutes or in hours. Then we can wait for that instead of switching on the system, water pumping systems. We can wait for the rain also. So, and also the amount of depth water, for example, based on the crop types, we can know how much water that need to be pumped in a particular zone. So it depends upon the root structures, root penetrations in the soil, or depends upon the soil structures. So these are the additional intelligence that need to be added to this type of application systems. So as I mentioned, for a physiological system monitoring, particularly heart organ monitoring systems, instead of just measuring all biological parameters and then providing a medical treatment, we must understand the emotional conditions of an individual or a subject while delivering a medical data to the doctors or to the any kind of computer aided dynamic systems, and also emotional conditions, physical activity of a person's, and also a surrounding environment. There is a very hot sun, I'm walking. Obviously, we'll find some variations in the functioning of the heart because too hot. So we must know that my physiological variation is due to the hot weather conditions, not any kind of a defects or infections in the heart. So the contextual informations, or you can say fusion of a contextual informations, are most important. Okay, in the case of this type of smart automation systems. So as I mentioned that one can make a joint decisions by fusing a various parameters. So that can be implemented on your on device or a edge device or a cloud computing. So therefore, this type of definition is still questionable, or we can have argument, but we have to see how much what we can see some difference between IoT and CPS by seeing these two definitions and descriptions. So IoT is a system of interrelated computing devices or mechanical digital machines, objects, animals, or a people enabled with unique identifiers. So if you see that smartphone, my smartphone is also enabled with the unique identifiers. Sometimes mobile identity. Somebody can identify who is giving a message from whose mobile. So every mobile has some identifier. Every computers which are connected to the internet world has identifier. That is already exist in the world. Then what is the new things in the Internet of Things that we are going to see? That's the ones still we do not have exact definitions where we want to have a distinct, that we can see that without requiring human to human and human to computer interactions. So such a things are, we can say, Internet of Things devices or Internet of Things systems. So that means what? The IoT technologies are mainly used to integrate cyber physical systems. So which can serve as an interface between cyber physical system and their users. Then what is cyber physical system? Sensing, computing, networking, and computer control components. Okay, it's integration of this. There are many cyber physical systems that can be seen in a vehicles, autonomous vehicles, and a healthcare, or in a space technologies or aerospace technologies we will find, and which will be integrated by using this type of Internet of Things technologies. And that's nothing but merging of IoT and CPS into a closed loop real-time IoT enabled cyber physical systems. So we can say if I merge both IoT and CPS concepts, then we are going to develop a closed loop real-time Internet of Things enabled cyber physical systems. But there are three dimensions which were proposed: anytime connections, any place connections, anything connections. So anything connection is possible because we are enabling the objects with a different kind of sensing elements and wireless modules. But anytime connections, any place connection is still a challenging problem in the world, because we'll always find a communication failure in many places. We can also see the network coverage problems. So even though we have network, but we'll see the communication failure. But there are many places we do not have network. Okay, so that's the things that how to resolve these two problems, address these two challenges. So now recently, Cisco in 2013, that with the concept of IoT, they try to introduce the Internet of Everything, where they try to integrate a people, process, things, and data. Okay, people means connecting people is more relevant and valuable ways. Process means delivering the right information to the right persons or a machines at the right time. Things means the physical devices and objects connected to each others and the internet. So that we are talking about Internet of Things. And data means leveraging a data into a more useful information for decision making. So nowadays you will find, okay, we are living in the world of data economy. That means if you create a huge amount of data, you can generate a huge revenue. If somebody collect a huge amount of different environmental sounds in the forest area, then we can develop so many products, and you can sell the data to the different industries. So similarly, engines sounds, similarly healthcare signals, similarly any kinds of informations. Okay, so now when you talk about artificial intelligence or deep learning based data analytics or big data analytics, so we must create a huge amount of data. The data must include a variety of informations in a different spatial coordinates and different temporal informations. Over the period of time in a particular locations, we can see the variations in the informations of a particular events. And similarly, if you move the same event observation in different spatial locations, the informations will be slightly different. So therefore, the spatial variant informations, and we can say demographic or we can say geographical informations, um, uh, also time varying informations are most important. Okay, so that is the concept of Internet of Everything's. So bringing together people, process, data, and things to make a network connections more relevant and valuable than ever before, turning information into actions. That's very important to create a new capabilities, richer experiences, and to also create a new economic opportunities for business, individual, and entities and different countries. So that's called Society 5.0 is targeted. Okay, we are bringing a people into the system to develop a very smart, we can say smart automated system applications. So for Internet of Things, we must know what are the different types of wireless technologies. So based on the transmission distance for effective data transmissions and then data rate, we can see the different types of wireless technologies. One is RFID, it's between in a meter distance, and then Bluetooth low energy, PLE, Zigbee, Z-Wave, then Bluetooth with the data rate of 1 Mbps up to that one, distance 10 meter, Wi-Fi, then we have Wi-Fi, HLO, then cellular, we can see 5G, 3G, GSM, GPRS that we have seen. Then nowadays we are talking about LoRa. So these are the different types of wireless technologies which are used in the Internet of Things platform or systems and devices. So based on the bandwidth, I just made a clusters from the different studies, faster studies. Okay. So in all these aspects, we have to consider these parameters. One is the range, power consumptions, bandwidth, radio chipset cost, radio subscription cost, number of base stations, transmission latency, and geographical coverage and penetrations. So this, based on these parameters, one can choose any type of wireless modules. Okay. So if I can compromise the power, power consumptions, then I can choose a very low cost chipset. But I want a low power wireless modules, then obviously the cost of the radio chipset will be much higher. When you talk about the high data rate, the cost will be much higher. When you talk about the longer distance, the cost will be much higher. So therefore, depends upon the overall cost of the final product. One can choose any kinds of wireless technologies which are listed here. So some more details you can find from this table, that WiMAX and then LRW, personal area networks and mobile communications and their distances. So one can develop this IoTs by integrating all this short range, medium range, long range wireless technologies. That also depends upon the applications. So what are the benefits of Internet of Things, which is also known as Internet of Medical Things? When we connect all wearable devices or biosensors with any kind of a smartphone or with the cellular networks, then that type of platform is called Internet of Medical Things. So what are the advantages or the benefits of this Internet of Medical Things? So we can see that lower expenses, better treatment results, better disease control, fewer mistakes, most trust towards doctors, medicines controls, better disease controls, maintenance of medical devices. Similarly, other applications you will find it. What are the sensors? We will find somebody can wear a wristwatch, which can sense the pulse rate, or we can say heart rate, which can also sense a glucose level, which can also sense a respiration rate. which can also sense a different physical activities, energy expenditures, which can also sense a galvanic skin response. So many kinds of sensors, or we can say we can find many kinds of miniaturized biosensors which are useful to sense vital sign parameters. So if you see that technology addressing the three main pillars of healthcare, one is affordable healthcare systems, quality healthcare, and healthcare access and delivery. That's very important. So I can access the health of remotely located persons by using this IoT platform. I can improve the quality of the healthcare by fusing different environmental parameters, because as I mentioned that this IoT platform is going to connect with millions of devices, okay? Each of millions of heterogeneous devices. So one has deployed a set of devices in a campus for continuously monitoring the air quality by the, we can say, Air Quality Pollution Control Board. Some other agency, water resource department deployed a set of sensors to continuously monitor water quality. Some department deployed healthcare sensors or kiosk type to sense the physiological parameters from a different populations in the campus. Now, every entity, we can say every agency, going to get informations for their applications. But if I fuse these three applications, for example, I'm talking, if I fuse air quality informations and water quality informations and health informations, then I can able to develop a intelligent, what we'll say, prediction mechanisms. It's a better, I can provide better quality healthcare service, or we can say quality healthcare. In the sense that this type of parameters also impact the health of the people, because if some zones you will find, let us take a Delhi, we are talking, there was a survey recently that one in third kids or children are having asthma. That is due to the dust pollutions, other air pollutants. So now zone specific disease diagnostic system, prediction system can be developed by fusing this type of parameters. So if heterogeneous devices are connected for a different applications, we can use that informations coming from the heterogeneous devices to develop new applications, new business, new products. That's why we have mentioned that it's going to enable the new kind of products, because interconnection of many devices. So we use the device for some applications, but the same device informations can be used for other applications also. By sharing the informations to the another agency, we can develop a new product, innovative products, or we can develop innovative solutions. For example, vehicle health monitoring. So you will find a vehicle is moving in a good road conditions or a bad road conditions. So the vehicle moving with the bad road conditions have what is called immediate problems with the engines, or some kind of a parts of the engines, or parts of the vehicles. Now, who will provide this information to the manufacturer or service provider or sales, or you can say agency, sales agency? If they are able to access the third-party informations like a road condition informations by the road safety department provided, then we can able to develop a best systems, or we can say onboard diagnostic box. So sensor devices, edge AI becomes popular in all these type of devices, which is useful to develop a smart city, smart home, and we are talking about smart healthcare systems. So what are the use cases and contexts? We have seen all these things, that data sensing and collection, data transport and access, data analytics, data value defined by actions that I explained in the previous examples, human values, arts and experiences, and device connections and connectivity. So these are the main use cases of this type of technologies. So in terms of IoT system architectures, there are many architectures are proposed. This is the recently reported in Internet of Things journals, which includes 5 layers: perception layers, mist layer, fog layer, cloud layer, application layer. That depends upon what type of computation processing tasks that are performed in each of the layer. So perception layer is nothing but sensing the data from different objects. That means interconnection of the object by using sensor elements, which also includes data transmission, or we can say wireless modules. Then mist layers, some kind of a rule-based pre-processing can be implemented. Then fog layer, you will find data fusions. As I mentioned, in some layer, you can fuse that data. When you want to monitor health of the persons in Delhi, I'll fuse the environmental data with the healthcare information coming from the mist layer and perception layer. That is, we develop as a fog layer data fusions. And data filtering can be done, data analytics, data compressions, which are implemented at the stages of data, that is fog layer. There is a cloud layer, which enables the big data analytics and long-term data storage, advanced machine learning techniques, and load balance. And then application layers that involves creating a different interface, user interfaces, for better visualization of this complex data, which are acquired in real-time applications. So this is also kind of a proposal. It is not necessary that one has to follow this type of architectures. One can propose new type of architectures with their silent features and their applications. So now, if we come to the Internet of Medical Things or Internet of Health Things or mobile medical Internet of Things, we divided these connected devices and systems of a healthcare into this category, that is subject to home. So that means what every person at a home is enabled with a set of wireless sensors, that is wristband, wristwatch, earphone devices, which are useful to sense the biological parameters from the human body, which can transmit the data to the home-centric computing platform. At the home, I have a server which always interact with the healthcare, interact with my sensors within that home zone, particularly elderly, monitoring the health of the elderly people or monitoring health of the infant or a baby. So now the complexity or design problems will be different for the subject to home healthcare monitoring system as compared to home to hospital healthcare monitoring systems, and ambulance to a hospital healthcare monitoring systems, hospital to hospital healthcare monitoring systems, hospital to ambulance, and then subject to caregiver and diagnostic lab to hospitals. So we can find a different what is called healthcare information flow. These are healthcare information flow from one device to another device, or one system to another system, or multiple systems to multiple devices, or multiple devices to the multiple systems also. It's called health information flow. Once that is subject to home, home to hospital, ambulance to hospital, hospital to hospital, hospital to ambulance, subject to caregiver, diagnostic lab to hospital. This is a health information flow. Now, by seeing this category, we can say groups, we can understand the complexity involved when you want to develop a intelligent healthcare monitoring system for the application of subject to home, for the objective of subject to home. Okay, so now with this I will highlight what are the challenges that we need to address when you want to develop a smart healthcare system for smart city. When you talk about smart city, it is developed for a healthy life of your people. You will find a different populations, in the sense that you will find populations in the category of different economic incomes or facilities available. And also you'll find smart cities enabled with various types of technologies. A smart city is connected with some kind of what is called industries. Smart city connected with different schools. Smart cities connected with different hospitals. Smart city connected with the different service providers, third-party service providers. Now, if you want to develop a systems for monitoring the health of the people in a smart city environment, then we must consider this type of technologies. One is what climate aware healthcare monitoring technologies, which includes a sensing of air quality parameters, water quality parameters, and weather informations, in addition to the health informations of the particular smart city area or a zone. So now you see the impacts of climate change on a human health. We will find the extreme heat and cold impacts, similarly air quality impacts, water quality impacts, and vector-borne disease. When we see the smart city, but still we know what is the definition of smart, but enabling the smartness in a particular project is not easy. There are many challenges. So we just to say smart city, but you will find the smart city is surrounded with the various water bodies. In the various water bodies, you will find different kinds of animals and insects are living. So that will also means create or generate a different type of diseases. So we must understand how do you monitor the water quality of that particular water body area in the surrounding area of a smart city, or if you find any industries located within the smart city or nearby smart city, we must know what are the air quality pollutants, whether it is in the nominal. If it is not in the nominal, we have to identify the solutions. We have to create innovative solutions to improve the healthcare of the smart city populations. So now if you see, in May 2018, WHO released the information that revealed that alarming toll of air pollution. That means 7 million deaths caused by exposures to ambient household air pollution each year. It is noted that 90% of the world populations lived in areas where air pollution exceeds WHO limits. There are many examples in the news. You will find that capital of India, that you can say in India, Delhi, highly polluted, and you will find this type of disease. So this is related to the heart, this is related to the brain, this is related to the lungs, and this is related to the liver. So we will find many people affected with respiratory disease if they exposed to dust particles. So these are the different air pollutants that need to be continuously monitored when you want to develop a internet-based smart healthcare system for a smart city applications. So the smart city areas should be covered with a set of sensors for continuously or periodically sensing the primary pollutants and the secondary pollutants in the zone. Then these readings will be used or fused with the health information of the people, either to provide what is called correct treatment based on the pollutants which are sensed for 1 week, or we can use this data for predicting what type of disease that we can expect from this type of area or populations living in this area. So these are the primary and secondary pollutants that need to be monitored by using IoT devices. So a set of air quality index were proposed and published in many newspapers and literatures, and some of the things we must know when we want to develop a system. This kind of index can be used to alert the people living in a smart city area. Because when somebody say that we are living in a smart city, it is completely depends upon the involvement of the people. That's why I showed in the first slide, when we talk about society 5.0, the cooperations and collaborative information sharing from the people is most important to exactly enable, or we can say to enable this type of smartness in each of this product, like a smart city, we say smart transportation. That means the involvement of the peoples play a major role. Otherwise, I am living in a smart city, but I never tested my vehicle smoke. So in that means, if somebody is using vehicles with the bad smokes, and then we can see that air quality of that surroundings will be changed, and that will also impact different type of disease. So the involvement of the people or collaborative information from people is most important. That means what? Every vehicles also need to be enabled with this type of IoT platform when you want to live in a smart city environment. So that means what? When I enter the smart city zones, my centralized system should collect the air quality parameters of my vehicle, so that information can be effectively used for predicting some kind of healthcare disease, or we can say healthcare information, or we can say that to provide the correct treatment. Because as I mentioned, the physiological information can be what is called change or variant, can be varied due to different environmental conditions also, in addition to any kind of infections or defects in the heart or any kind of muscles defects. We can find, okay, so different other factors also can change the physiological parameters. So therefore, we must understand this type of quality index, and these are some of the reports we can see. Delhi 437 for this pollutants of PM 2.5. So the PM 2.5, which involves the fine particles, lower respiratory tract flow. So you can find that PM 10 2.5, okay, then to 1 and 0.01, and you can find a different type of disease here and what type of infections we can see. Okay, PM 2.5 respiratory disorder, and then circulatory disease, allergy, cancer, eye disease, digestive disorders. So if I have a PM 2.5 sensor in at every home or every vehicles or every smart city and in multiple locations of a smart city, and then we are able to identify this type of disease, that respiratory disease, digestive disease, eye disease. We can have correlations. It's up to us how much we correlate this type of environmental data with the human diseases, whether it's a communicable disease or non-communicable disease. But this is also a survey which shows how much concentration of PM 2.5 and in each of this country, and India is 58.1, and in particularly Delhi 98.6. So these are the most important study which you need to consider when you want to develop the Internet of Things healthcare systems for smart city applications. So another thing is drinking water quality, that also impacts. So even though we live in a smart city environment, that interconnection of the water pipes always crosses the sewage systems, or any kind of damages in the interconnection of the pipes can mix with the rain waters, and that mix with some other bad quality of waters, or this water can mix with some other chemical waters coming from an industry, or the what we'll say inorganic, or we'll talk about the farm chemicals, or any kind of animal death, decompositions, and So if we can find the water, drinking water qualities are highly polluted in different regions, and then we will find various kinds of disease which are related to the quality of drinking water, and then we can find that 785 million people lack even a basic drinking water service, including 144 million people who are dependent on surface water. So there are many kinds of sources for collecting a drinking waters: surface water, borehole waters, then rain waters. If you see the borehole waters, that will have a different contaminant pollutants, okay, which need to be purified and which need to be checked. Similarly, surface water has a different type of pollutants. So that related to cholera, typhoid, diarrhea, some malaria, other diseases which need to be further studies. And similarly, extreme heat in the smart cities. Any smart cities cannot be escape from this type of extreme weather conditions. Not only cold, it's also extreme sunlight. Always this, all the cities are exposed to this type of environmental factors. Okay, extreme heat, you will find many people die. So that means we must have some kind of a sensors which can continuously sense and alert the populations lives in the societies to take some kind of precaution or some kind of actions. So these are the things we can see, that greater than 45 degree, that's avoided. 45 to 44.9 degrees, that's avoided, and 41.42.9, that's avoided. So now you can see temperature threshold. What is, you will find, this is a small survey. Okay, 1,100 deaths annually. Okay, due to the extreme heat. Similarly, extreme cold also, it will highly impact the health of the people. So now we have seen different climate conditions and we can say environmental factors that impact the healthcare. Now we have to see what are the different type of devices and systems, applications we can say. We can use wearable devices. So as you mentioned that data, things, process, peoples are most important for smart healthcare systems, in particular smart city applications. So this is the good examples for continuously monitoring the pregnant woman, health of the pregnant women. So we used, they used finger pulse sensors and then respiration sensors, and also to sense different other physiological parameters. Then that is collected by using smartphone and then transmitted to the cloud, or directly it can transmit to the cellular tower, then it to the cloud. So this is bedside IoT enabled healthcare monitoring systems, and this is, we can see persons at the remote locations who is delivering informations. As I mentioned, when you want to monitor the health of the persons remotely, we must fuse all contextual informations. Otherwise, it may lead to a wrong diagnosis, because we do not know what is the conditions of a person who is delivering healthcare information to the hospitals. He may deliver data while drinking, or he may deliver a data while smoking, or he may deliver a data while walking. So all these contextual informations that need to be used if you want to provide a correct treatment, or if you want to perform a correct diagnosis. So this is the examples of IoT for continuously monitoring health of the elderly people or fitness of elderly people. So these are a very, we can see there are very different kinds of wearable devices which are used for sensing different physiological parameters and fitness parameters. And then application of Internet of Medical Things are grouped into body-centric applications, object-centric applications. That is indoor, outdoor, indoor and outdoor. So in the indoor, outdoor or body-centric is sleep monitoring, heart rate monitoring. These are few examples. But you see smart healthcare system. Every device is nowadays called a smart. But as I mentioned, we do not know what is the smartness in the wristwatch. Previously, I was using analog watch to display only time. The motivation of that type of industry was like providing a time to your people. They design analog watch. But my motivation is different. I want to use this type of wristband for monitoring healthcare. So it means I should not blame that yes, the X companies develop analog watch for providing timing. That is the limitation of that. That is not a limitation. Their motivations to provide the timing information to the user. My motivation is to provide the physiological information to the user. Now, if the device is just used as a sensor to collect physiological parameters from a human body, then that do not have any kind of intelligence or smartness. It is just sensing. It is kind of a sensor. It's a sensing mean. Sensor means it's going to sensor any physical variable. It is transmitted to the cloud. That's all. It do not have any kind of intelligence. Then what is the smartness here? What is the smart ring? Everyone wear the rings, gold rings. Gold ring is gold ring wearing is a kind of a prestige issue. But if I put some electronics inside that to sense the pulse and sweatings and sense what is called glucose level, then it's become what electronic ring. Okay. Otherwise, I can say I developed a ring. Okay, ring-based system, ring-shaped system to monitor this physiological parameters. But the material that used for developing a ring-based system is a gold instead of any plastics. It depends upon the cost of the people, means cost of the device. Then what is the smartness here? So if you want to say that the ring is smart device, that ring should be able to do some kind of actions. Not only just sensing, it should also perform actions in addition to the sensing and transmission of a data. It should perform some kind of actions, control actions. It should interact with other device. So we can say some kind of device-to-device communications, or interactive device communications, or body-centric device communications. So still we do not know what is smartness here. So, but one thing is that it can control other function of other devices based on the physiological parameters which are sensed on palm on your hand. If my glucose level is low, means the glucose is very high. Okay, the sugar level is very high. Then I can pump the insulin. That means I can control the function of the drug delivery system. So this is called interactive joint decisions. Both can make a joint decisions. Then we can say some extent we are providing intelligence to this type of devices to make some kind of decisions or actions, to perform some kind of actions. Okay, then only we can say these things are smart watch. Otherwise, just putting a sensor and getting a PPG with the timing, it's not a smart watch. There is no smartness in the watch. It is an electronics watch. Electronics watch is fused with a set of sensors. But the definition is we are just wearing, but it should perform some kind of actions which can, without human interventions, without machine interactions. I am not going to interact with this type of wearable devices, but it can continuously sense my glucose level and automatically it can deliver the drugs without human interactions between these two devices. Then we can say somewhere we are able to provide intelligence to this type of devices or smartness to the devices. Otherwise, just sensing and displaying there is no smartness in the world of any kind of wristwatch. So we just kind of devices with electronics components. So what are the challenges that we are seeing in the medical devices, in particularly body area networks? You will find so many watches, electronics watches, which some watches sense physiological parameters in addition to the fitness parameters. But all these watches has limitations. This type of watches can be used only for sensing the physiological parameters under resting conditions. These type of devices are not tested even for many pathological conditions and also exercise conditions. Under exercise conditions, the sensor which are embedded with this type of watches are more prone for different kinds of artifacts. So a single artifact or multiple artifact signals can provide parameters which also can be within the normal range of physiological parameters that may lead to a wrong diagnosis, which can be a false alarms, it can be a true alarms. But the parameters are extracted from the noisy data. So how do you provide the intelligence to this type of devices? That means what? Noise aware devices has to be developed. That's very important. Otherwise, if any algorithm sends parameters from a highly corrupted biomedical signals, and it always gives some kind of a readings, parameter values. That values can be within the range, because we say 60, for example, 60 to 100 beats per minute. From the highly corrupted abnormal heart rate behind 120, we can say 100 pulse rates or below 60 pulse rates, my algorithms can give 80 instead of 100 120 because of the noisy. So that leads to a wrong diagnostic. That means what? Basically, the abnormalities are detected as they are normal. Some cases, I do not have any biomedical signals due to the sensor disconnections, but your sensor may produce some kind of a readings for high amplitude artifacts. So these are the things that further need to be studied when you want to say this type of devices can be used for monitoring health of the people under different physical activity conditions. Yeah. So in addition to the sensing challenges, we can also see some of the challenges in the computation. Let us take the previous examples of watches, or we can say body-worn devices, wrist-worn devices, ear-worn devices, which is used to sense, or we can say acquire the signals and transmit to the cloud. But I want to sense and display the pulse parameters, respiration rate, body temperature, glucose level on device itself. That is called on-device processing. Because if we just sense and transmit, many users, many consumers will not buy. But if I display something on the devices, or you can say if I provide some kind of intelligence to the users, then you will find a huge market. So therefore, you see that user interface design is most popular in addition to the technology development. Otherwise, we will not get a good market even if you have high-end technologies. So therefore, the displaying all these vital sign parameters on a device becomes most popular. That demands a lightweight signal processing techniques to extract all these parameters, vital sign parameters. So that's called on-device computation. But when you say on-device computation or on-device feature extractions or vital sign parameter extractions, we need to consider the resource constraint of this type of battery-operated devices, because we are aiming for a lightweight, miniaturized sensors, lightweight watches, miniaturized sensors, so that it's more comfortable for the users, can vary with the less lightweight. So that miniaturizations in terms of sensors, in terms of size of the watches and any wristband devices, we can see the degradation of the signal quality. Okay, so therefore, the extraction of accurate, reliable parameters on a device highly demand a lightweight signal processing, because these wearable devices are resource constrained with limited battery power, limited memory, limited processor speed, and limited data rate. Or one can move this type of feature extractions to the smartphone, because you will find a people who will carry both. They will also they are wearing a wristband and also carrying a smartphone. You cannot find a person nowadays without a smartphone always. You'll find always he carry a mobile phone. Always you'll find sleeping time also you'll find a mobile phone close to the bed. So now you can use the smartphone to aggregate the data from this type of wearable sensors of the body, and then all these vital sign parameters can be extracted from the smartphone. With the assumption of that smartphone has a better energy power, means battery life as compared to this type of wrist devices or ear-one devices, but only they can deliver the data to the smartphone. Therefore, the smartphone can be used as a data aggregator. So then, once we extract the parameters, that can be displayed. So, but we have to always sync the wristband with the smartphones. That's this type of technologies you can see nowadays. When you buy any wristband, it always syncs with this type of wearable devices, the smartphones. It can sync with your computer also. So in all the cases, the edge computing on-device computing is become most popular as compared to cloud computing by considering this type of benefits. User privacy and data securities, because we are not transmitting data to the cloud. We are computing everything on device and edge computing, so that can provide a better user privacies and data securities. And the latency is reduced because we are not transmitting the data. And communication failure is not a major challenge here because everything is computed on a device. And the network coverage is not the most important for some application of wearable body area networks. The bandwidth utilization cost, mobile network usage cost, and then data rate cost, treatment cost, all the cost can be reduced if I can develop a systems with on-device processing or edge computing processing. And further, we can improve the lifetime of the batteries. And if we develop any kind of lightweight signal processing techniques. So these are the major benefits of edge computing, on-device computing. You will find there are many technologies nowadays: edge computing or on-device computing, IoT edge computing, IoT on-device computing. So these are the advantages. So what are the challenges when you say that my device is connected to the internet or connected with other devices? The security privacy is most important. The privacy is most important for healthcare informations, but nowadays, if you just ignore the privacy and if you give more emphasis to health of the or life of the people, then the privacy is not the most important. You will find nowadays there are many people in the category of diabetes, and every day they interact with each other. What is your sugar level like this? So the privacy is not that much very important if you give importance to the life of the people. But the security of the data is very important because there are many enemies in the world of competitive business. So one can change the security of the device, means one can change the conditions of a device or data acquisition process of the device. One can change the data, acquired data. One can change the amount of a drug that need to be delivered. So these are the security challenges that are involved in the connected devices or connected systems. So what are the device management that we need to consider? One is the backend device management, edge device management, IoT applications, IoT device management, where we have to consider device deployment and device lifecycle management, device security and device connectivity, and device connectors that I told you. Sometimes under different physical activities, the device can be disconnected from the sensing side. If there is no connectivity due to the poor network coverage or communication failure. If there is a poor securities, one can change the physiological data, then it can lead to a wrong diagnostics. Then IoT gateway, embedded softwares that need to be developed for IoT devices. So these are some of the research components in the category of device management. So as I mentioned that, how do you use AI in the case of your smart healthcare systems? So one is based on biomedical data computing platform. Means that we collected a data, we can compute on device, on a edge, on a cloud. Based on that, we can group biomedical data computing platform into wearable device computing, portable device computing, smartphone computing, home-centric computing, cloud computing, or hospital-centric computing. Each of this computing group has some advantages and the limitations. Device computing, the hardware resource will be different. Portable device computing will have different hardware resources. Smartphone will have different hardware resources. Home-centrics will have different hardware resources and the other benefits. So therefore, we must understand that what type of computing platform that we are going to consider if you want to develop, or we can say consider for developing AI-based healthcare systems. And based on health monitoring strategy, we can categorize into three. I listed two. One is supervised health monitoring group or strategy, semi-supervised health monitoring strategy, unsupervised health monitoring strategy. In the supervised healthcare monitoring strategies, where we will find all these devices going to use to record the signals, but all the parameters and diagnostics done by the doctors and experts in the hospitals. And then semi-supervised, so you have few set of parameters that can be extracted, and then based on that few set of parameters, the device can recommend type of arrhythmias. If you go to hospital, they'll put a ECG electrodes and they'll take a paper. If you see the ECG paper, you'll see the waveform in addition to some kind of type of arrhythmias. So we are using these devices not only for sensing, it is for extracting parameters and suggesting the type of disease or type of arrhythmias to the doctors. However, doctor is the final decision makers. So that's called semi-supervised healthcare monitoring strategy. But the challenges are different for different strategy. Unsupervised healthcare monitoring is completely, we are trying to remove the expert interventions. That means the device will take immediate actions to activate other device or deliver any kind of a drugs to the human body. That is called unsupervised healthcare monitoring, but there are some limitations that involve. Then based on the patient monitoring strategy, one is bedside monitoring strategy, remote patient monitoring strategy. The limitations and the challenges are different for a bedside patient monitoring and remote, because bedside patient monitoring means we can gather the complete information about the environment and its emotional and body behaviors and other behaviors also. But if it is a remote patient monitoring, all this behavior and the environmental conditions that need to be sensed in simultaneously and need to be transmitted simultaneously with the biomedical signals for better treatment process. So therefore, the remote patient monitoring, it has advantages because it can reduce the frequent visit to the hospitals, but there are many challenges. It's very difficult to understand whether this parameter changes due to this type of infections or defects in the different organs of the human body, or it is a lifestyle, or it is environmental factors. And then biomedical data, based on biomedical data sensing strategies, and we can say contact-based signal sensing, contactless-based signal sensing, and each of these sensing strategies will have different limitations. For example, for infant and elderly people, we like to use contactless-based sensing. But if I use contactless-based sensing, but it is difficult to or capture or acquire a fine detailed informations like a ventricular late potential in the ECG signals. In the case of a contactless, because most of the literature studies you will find that contactless based for extracting only high level like features like a pulse rate, heart rate, respiration rate. But if I want to have perfect P wave variations, P wave duration variations, P wave amplitude variations, or ventricular late potentials, and the shape of the QRS morphologies or heart murmurs, then we have to use always contact based, because contact based sensing can provide a high resolutions with the fine detailed clinical informations or best resolutions can be obtained. So there are many limitations and advantages for each of these categories and groups that need to be addressed when you want to develop climate or healthcare monitoring systems. So finally, I like to summarize. These are the main challenges: acquiring a good quality of your biomedical signals, ensuring reliable clinical evaluation under different physical activities and emotional stresses. Even if you live in a smart city, we do not know the different psychological effects of the people living in the society or different physical activities. That information has to be fused. How do you validate the accuracy and reliability of medical softwares? Because if I develop one medical software for resting conditions, it may not be suitable for extracting the same parameter under ambulatory conditions and exercise conditions. How do you manage the battery power in the case of continuous long-term health monitoring applications? How do you secure connected medical devices? You will find there are many enemies for many people, that one can tamper or alter the function of the connected devices. It may provide a wrong information to the doctors, or it can provide a what is called wrong drug amount or quantity. Then how do you secure the data of your medical devices? That's also a challenge. That is called data security. Challenges in integration of multimodal devices and information processing systems, because as I mentioned, air quality parameter, water quality parameter, weather parameters, and physiological parameters, all that needs to be connected, coupled tightly, and we have to fuse with a very good big data analytic platforms, and to predict and prevent different type of diseases in a smart city environment. Who owns the consumer generated medical data set? There's another interesting issues. The designing user-friendly interactive interface is most important. So these are major challenge: signal quality, which leads to false alarms. The data security is one of the major problems, and then contextual information diagnostic accuracy, and then power consumption, battery life. So thank you. So any questions from the participants? Then
Participants, if you have any kind of query, please ask.
any questions from the participants?
No, sir.
Yeah, any questions?
Okay, thank you, sir. Thank you for the session. It's really very informative session. Starting from different types of society 1.0 to society 5.0, and evolution of internet, smartphone